Hello, Honors Chem students. Mr. Keister here with you again today. This is the video for Friday, October 16th, 2020, our scheduled 41st day of school for the fall semester. Oh my goodness, today is the last day of the first quarter. Quarter one is over after today. We've gotten through half of the first semester already in 2020. Wow. Woo. Went quick for me. How about you guys? Anyway, keep in mind though, the dates could change for a variety of reasons, but the lessons and the order that the lessons are given, of course, will remain the same regardless. So this is a short video today. Yippee. Because we have, I should say, you have work to do, several things to do, and so let's get to the do-nows and discuss that, and then I will sign off and let you get to work. So today we have, you're going to pick up your new notes packet for Unit 3.2, which is over nuclear chemistry, and first assignment there. Yesterday, you picked up the review for Unit 3.1. Of course, Wednesday was PSAT day, so we weren't in class. Tuesday, you picked up the binder list for your first quarter binder. That's something that needs to get done. So anyway, let's talk about that. First, homework for Tuesday. Monday is fall break, all right? Monday is fall break. Nice. So for Tuesday, you are to complete the nuclear chemistry assignment that you picked up today. All the questions can be answered from the note packet. It is due Tuesday, beginning of class. I'll be collecting it for a grade. All right. I will briefly start the notes today, but not go very far. It's not going to take long, believe me. You are also to watch the videos over the nuclear scientists in Canvas. They will supplement your reading in the notes. Please watch them, all right? They are on the calendar, all right? They're on the calendar. Online homework. Your next online homework assignment in mastering over atomic structure is due this coming Tuesday, the 20th, by 7:30. So you can be working on that today, too, if you run out of things to do, which I don't think you will. Next, your first 9 weeks binder is due by the end of class today, and it is for a grade, so you will be leaving me your binder today. If you get it to me quick enough during class, I'll get it back to you before you leave. If not, you'll pick it up Tuesday. So you'll want to make sure that you keep out your work for your notes packet and your new assignment and so forth. Your papers must be in order in your binder according to the list. Hopefully you've been keeping up with that during the 9 weeks, and so that shouldn't take too long. Lastly, of course, enjoy your long weekend and fall break day off this coming Monday, and I will see you Tuesday. So let's do a quick start on Unit 3.2, and then I'm going to let you work the rest of the time. So let me pull that up over here. Give me a minute. Well, not a minute, but there we go here. Okay. All right. So just a quick introduction on nuclear chemistry. All right. So we're going to talk about radiation this unit. High energy particles that have no mass that are given off by different objects are called electromagnetic radiation, or EMR for short. EMR moves through space as packets of energy called photons. Okay, so a photon is a massless particle that carries electromagnetic radiation. Now, we have certain types of waves, water waves and earthquake waves, whereby mass particles of solid material, particles of water, carry the energy of that type of wave. Those are called mechanical waves. Electromagnetic waves, however, their energy is not carried by massed particles. They don't need any mass or matter to carry their energy. Instead, they use what we call a photon. We'll talk about the discovery of those in either, well, somewhat in this unit, even more so in the next one. So anyway, photons carry the energy of electromagnetic waves, which is how electromagnetic radiation is carried. Each photon is a certain quantity of energy that is associated or characteristic of that particular type of EMR. The different types of EMR are determined by the range of energies given off by each, and the entire range is called the electromagnetic spectrum. The spectrum shows the different types of EMR and the relative amounts of energy that each gives off. So these are different types of EMR: radio waves, TV waves, microwaves, infrared, the visible spectrum or light, ultraviolet rays, which we commonly call UV, X-rays, and gamma. As you go left to right here, as you go from radio to gamma, the amount of energy associated with that type of EMR is increasing actually quite dramatically. I have a little vertical line here. This is kind of a separation between non-ionizing radiation and ionizing radiation. Low energy radiation or non-ionizing is not harmful to humans or other living beings or living cells, and is found from the visible spectrum on down to radio. All right? We can be inundated with this type of radiation, and we are on a daily basis, and regardless of the quantity or the time of duration, it is not harmful. The radiation is not powerful enough, not energetic enough to cause mutation or death to living cells. All right? However, up here, beginning with ultraviolet and increasing in energy as you go from UV to X-ray to gamma ray, those are what we call ionizing forms of radiation, which do have the ability to mutate and or kill living cells. And so we got to be careful around those. All right? We got to be careful around those. So ionizing radiation, which includes not only UV and X-rays, but also nuclear radiation, which emanates from the nucleus of certain atoms, such as alpha, beta, and gamma particles, has the greatest energy and potential harm to humans. It is more greatly concentrated and can cause severe damage to living tissue in a relatively short period of time. All right? So nuclear radiation results from changes in the nucleus of certain atoms. Some atoms have an unstable nucleus. They're overly energetic, called a radioactive nucleus, which is a nucleus that can change spontaneously to the nucleus of a total different atom. And it does that by this process, radioactive decay. It usually results in the production of the nucleus of a smaller atom, an ejected nuclear particle or particles, and energy. This is how a radioactive atom gets rid of its energy, by undergoing decay. It does this spontaneously so that it can go from a highly energized state down to a more stable energized state. And so a radioactive nucleus undergoes this process spontaneously called decay, gives off a new nucleus, an ejected particle, and energy. These ejected particles here, alpha, beta, gamma, etc., and the energy is together is what we call nuclear radiation. Again, nuclear meaning it comes from the nucleus, all right? And that's, folks, as far as I want to go today. Just a very brief introduction on EMR, and we will continue on with that, starting with our nuclear discoveries when we return to school on Tuesday. So make sure you do the assignment, read the notes, complete the assignment. I will be collecting it on Tuesday, and watch those videos. Right? Again, they will be a great supplement to the lecture on Tuesday and give much more information than I certainly can in just telling you. All right? You need to see what the experimentations were. So Until Tuesday, everyone. Work hard the rest of this period today. You got lots of stuff to do. Don't forget you got a mastering due on Tuesday as well. And until then, I will see you. Enjoy your long weekend. Enjoy your day off Monday. And I'll see you back again Tuesday. So until then, stay safe, take care, keep working hard, and stay focused. And I will catch you on Tuesday. So long, everyone. Enjoy your time off.